This is a review on how masks actually work, where importantly the influence of aerosol size and type on filtration performance is nonlinear and non-constant, and that filtration efficiency decreases with an increase in the gas flow rate, and that overall fitness of the mask plays a decisive role on how protective it is. Well, what does this mean? It means that the airflow around you impacts how effective the mask is, the aerodynamics of the mask itself, so how does the air flow over the mask, the type of particles that are contacting the mask itself, which includes how big those particles are, what the temperature is outside, because the hotter things get, it causes things to expand, and then filtration parameters of the mask. So this is the thickness of the mask, the fiber diameter within the mask, and then the fiber packing density is how tightly knit these fibers are together. All of that plays a role in how effectively these masks will decontaminate, quote unquote, through filtration, efficiency, and fit. So the big three we're going to look at are cloth masks, surgical masks, and N95s. And under a microscope, you have the cotton fiber. Under the microscope, you have the N95, which is matte-blown polypropylene. And then you have the N95s, the non-woven matte-blown polypropylene. So these cloth masks have relatively low filtration efficiency because they have thick fiber diameters and therefore large pore size. So under the microscope, you can see all these light areas. That is pore size. That's where you're able to sort of drop through the mask. And because that's visually seen, that means they're very large compared to a virus and compared to spittle. Importantly, if you are using cloth masks, you can increase the efficiency of these by increasing the number of masks that you're wearing. But as many of us have already found out, this increases the respiratory resistance. It's harder to breathe and increases the discomfort because they're hotter, there's a lot of moisture buildup, and this all makes it difficult to wear them for a long time. But this is something that you can do in the short term if you're short on N95s or even on surgical masks. Now, jumping to N95s, they have a high filter efficiency, they're resistant to oil, and the inner and outermost layers of these are hydrophobic. So they prevent water from being absorbed into the mask itself, which is really good if you're sweating and exercising in them. Additionally, they have acrylic supports to provide shape and thickness for the respirator. And again, these pores are only seen microscopically, see 100 micrometers, which means they're much more efficient at blocking out viruses from penetrating them. Now, these are all the different ways that masks can block viruses. In low-flow environments, gravity sedimentation is basically, it just kind of moves around. Inertial impaction, the spittle hits and bounces off. Interception, the airflow itself just kind of causes it to go boop, and then it sticks to the mask. Diffusion, the particle penetrates slightly but gets stuck. And electrostatic attraction, so the positive or negative charges just kind of stick to the outside of the mask.